So we will do these problems. Definitely you're going to have a fair amount of problems, probably like 3 or 4, that are straight up find the derivative. And so they're mixed together. You're not told what method to use, and that's very important. If you're not using the correct overall method and doing something completely wrong, then you're not going to get a whole lot of partial credit either. So it's pretty important to have the overall rule down and to be doing the right thing. So for this first one, also there's there's 2 multiple choice problems that I describe on the study guide that will tell you just what is the overall rule to use. And you don't actually have to find the derivative. You just, what's the overall rule, circle one of the choices and move on. And these are exactly the choices you're going to have for those. So make sure you look at the study guide for that. And I have some examples of that also on the practice exam, or the practice, because it's more than one practice exam put together, or more than one old exam put together. It's like probably like an exam and a half, because I just want to give you more examples. All right, so with that having been said, what's the overall rule to find the derivative of this function? Chain. Very good. Now some people might say product rule or something, but notice that it says natural log of all that stuff. So that is a composite function. It doesn't say ln x, parentheses that junk. Then the overall picture would be the product rule, but this is definitely a composite function for which we need to use chain rule. So the chain rule is the one that it's kind of more trouble than it's worth to deal with the notation, especially when things get kind of complicated. So the idea here is take the derivative of the outer function, evaluate it at the inner function, which means the outer function here is natural log. You know, what's the derivative of natural log of x? 1 over x, okay? So the derivative of the outer function evaluated the inner function for this looks like 1 over replace x with the inner function. So it's kind of a lengthy thing, so I need a little more room here. And I just write it down. And try not to get overwhelmed by the fact that that thing's super complicated. You know, we're just doing this initial step. And then now comes a time where we have to worry about that a little bit and say, hey, we need to take the derivative of the inner function. So the chain rule says to take the derivative of the outer function, evaluate the inner function times the derivative of the inner function. So here I'm going to give myself some time to think about that, and I'm going to write down what I need to take the derivative of. So that is a problem in itself. Just so you can kind of see how the parts fit together, I'm just going to kind of do this nesting thing where I'm going to kind of work on each part separately, and then we'll put it all together. So first of all, I should probably write this fourth root as a power. That's something I should do. So it's going to be a 1/4 power of that whole thing. And so how am I going to take the derivative of that? Chain. It's another chain. So the outer function is the power 1/4. Okay, so let's tackle that. I drop down the 1/4, write down the inner stuff. Again, I'm not really caring what it is, it's a function of x. And then what is the new power? -3/4. So I'm just taking 1/4 minus 1. And now the chain, to finish that out, I have to take the derivative of the inner function, which now is cosine of x to the 8th power. All right, so I wrote that d over dx notation up front to say, like, okay, now it gives me a pausing point where I can now look at this and just try to do that problem. What is the derivative of cosine of x to the 8th power? So chain it again, right? What's the other function? Cosine. What's the derivative of cosine? Negative sine. Very good. Oh, the original inside stuff, x to the 8th power. And then we can finally finish this and take the derivative of x to the 8th, which is 8x to 7th. Okay, now I just got to reassemble this, and I'm done. Because we don't have to simplify, I can just go ahead and write out the package deal here. and then not care if it's pretty. But you do need to write it all together at the end here instead of this weird stuff I did here. So what I had was the derivative of that big thing, and then for part of that we got 1/4 times cosine of x to the 8th to the negative 3/4 power over all. Then that was multiplied by negative sine of x to the 8th, and then we also have to multiply by 8 times x to the 7th. So sometimes people get confused on how this is all put together. It's just a chain of things being multiplied overall. So it's just a bunch of stuff being multiplied all together. It's not like they're getting embedded in each other or something like that. So that's the result. Questions?